All right, so I wanted to go over a few of these with you guys, so that way you guys can see how to do some of these. But here we're asking what is f of 0? So this is what is f when x equals 0? Well, x equals 0 is here. F is the line down here. So that's the reason why f of 0 is -2. Okay? And then f of 3, same thing. So when x is 3, what is f? So 1, 2, 3. Well, it's right here. That's 3, 0. So f of 3 is actually 0. Oh, I don't want that. Actually, I don't want that at all. Okay, and then f of -3. This one's a little bit harder because where it's positioned. So when x is -3, you got to kind of go down here, and it's supposed to be at -4. I know it's crooked, but f of -3 is -4. Okay, this is a little different. Okay, it's saying when. So remember, when it's when, you're looking for the x value. Okay, so it's saying when your graph is 0, what's your x value to make it 0? Well, wasn't f of 3 equal to 0, right? So basically it's saying this is kind of a fancy way of asking what is the x-intercept. Well, the x value of 3 gives us an output of 0. So that's the reason why x equals 3 is the answer. Domain, left and right, it's going to go left and right forever. Okay, all linear functions don't have any restrictions. So kind of the domain is are there any restrictions in your inputs? Are there any values you're not allowed to put into a linear function? And there's not. You can plug in any value. There's no restrictions. Like there'd be restrictions if you had like 1 over x, right? If you had 1 over x, then you wouldn't be allowed to plug in 0. So that graph would have restrictions on the domain of 0. Okay, but this domain is all real numbers, which is using interval notation, -infinity to infinity. I don't know why it's doing that little shade thing around it. I hate it. Okay, what is the range of f? Okay, again, even with looking at your function here, it's going to go up and down forever. Okay, and there's like the outputs of a linear function if the function is not a constant function, will reach -infinity and infinity. Okay, and then here we have ourselves a constant function. Again, what is g when x is 0? Well, it's right here. 1, 2, 3, 4. It's at 4. It doesn't matter which value it is. It does not matter. I can go to infinity and it's going to be 4. So g of infinity is 4. G of 2 is 4. And then here's that kind of funny one where it's when. So we want to know what x value gives us an output of 0. So when will it reach a y value of 0? So when will it cross the x-axis? It never will. So that one right there, the answer would be no solution. So you can either do an empty set, or you can actually write in no solution. Okay. When is g of x greater than 0? So when is this line above the x-axis? It's always above the x-axis. Always. All real numbers. So all x values will produce an output that's greater than 0 because all my y values are 4, and 4 is greater than 0. All right, what is the range? So how high and low will it go? What are my outputs? My only output is 4 because it's a constant function. So it's kind of different. Okay, number 12 here, we have when. So again, we're looking at x values. When is that f of x equal to g of x? So we want the x-axis when they're equal. We want to know what x value. So basically, that x value right there is where they cross. So that x value is 2. So you can put 2 or x equals 2. Okay. Here it's when is f of x greater than g of x? So when is the f line above the g line? Well, f is above, it's above, it's above, it's above. And then when they intersect, all of a sudden now it's below the g line. So I want everything to the left of 2. Okay. So it's either the left or these sort of questions, it's either to the left or the right of the x value of where they intersect. So this one's to the left. So this is going to be negative infinity to 2. Now, since that's just a greater than, there's no equals to, we're not including the equals to part. We're not including it. So that's why we're going to use a parenthesis. A bracket includes it. Okay, we're not including the 2 because we just want when f is greater than g. Not when they're equal, only when it's greater. So everything to the left of this. Okay, and then when is g greater than f? Well, g goes above f to the right of 2. But we want equals to as well. So we're going to include 2, and then we're going to go to the right, which is to infinity. Okay? And now, remember, you always want to go, when you're writing these intervals, it's always least to greatest. You can't say 2 to negative infinity. You cannot do that. You have to write negative infinity to 2 because from left to right. From left to right. So that's why it's 2 to infinity. That's why it's negative infinity to 2. Okay, and then what is f of negative 2? So let's go to the x value of negative 2. And where is f? Oh, f's right there at 2. What is g of 1? So if I go to 1, where is g at? G's down here at negative 1, 2, 3. Okay? And then if you look at 13, all right, so a lot of these answers are going to be separated by that intersecting point at x equals negative 2. So negative 2 will be in these answers, these integrals. Okay, so if I want values when g of x is greater than f of x or when f of x is greater than g of x, I'm going to use negative 2 in there because that's what separates them. So if you go to the left here, f is above. F's above g. If you go to the right, g is above f. Okay, and then these two questions are the same. When is g equal to f? Well, when we're looking at x values, right? When x equals negative 2. They're the same. Because when x equals negative 2, they both have an output of 3. That's the only place where the same input gives them the same output. Okay, and then when f is g, it doesn't matter. 3 is equal to 3, or, it just doesn't matter which side. They're equal. Okay, so you guys should try these. All right, it's either going to be to the left or the right. Since it has an equals to, you're going to have a bracket. This one, there is no equals to, so you will not have a bracket. All right, so enjoy.